So in this video, I'm going to lay out the law. A little math humor there. We're going to talk about the law of sines. And sorry. We're going to start with something we know, though. You guys have already been working with just a regular right triangle. And so this is kind of a classic. You may have seen this shirt where it has a right triangle and it says find x, and someone humorously circles the x and goes, there it is. Which is really funny, but it's not that helpful though, right? Because when they say find x, what they really mean is to find out the length of x, and just goes to show you that teachers need to ask very detailed questions to be specific in what you want, because technically if I said find x, then you've done that. So what I really mean is find the length of x, or the value of x, if x represents the length of that side. Okay. So, and we know how to do this because we know this relationship that the tangent of an angle is equal to the opposite over adjacent. In terms of 25, the angle we know, 8 is the opposite side, and x would be the adjacent side. So we could set up this little relationship, tangent of 25 degrees is equal to opposite, which is 8, over adjacent, which is x. So we multiply both sides by x. To solve this, we multiply both sides by x, and we get x times tangent of 25 degrees is equal to 8. Divide by tangent, and we get of 25 degrees, we get 8 over tangent of 25 degrees, and we grab our calculator. I think I have a calculator on here. Yeah, there we go. Grab our calculator, and we take let's see, do I have trigger yet? 8 divided by, grab a trigonometry section, tangent. Oh shoot, I should do that first. So let's see, how do I do this? Let's do clear. Every calculator has its own language. Let's go degree. Oh, no, degree. Degree, okay. So let's go 25 trigonometry tangent. So that's the tangent of 25. We want to divide that into 1. So we're going to put a little can I do this? Oh boy, figuring out calculators. So what I want to do is 1 divided by parentheses. Now we're going 25 trigonometry tangent close parenthesis equals. There we go. So we get approximately equal to, and I've lost my calculator, what was it? 2.14. Okay. 2.14. So the length of that side, of course it doesn't really look like it. Yeah, this is a good lesson, and you got to know how to use your calculator. And Evelyn and I don't know how to use the built-in calculator in my computer, because that is not right. How do we? And this is actually a great lesson you should always do this. How do we know that 2.14 is not right? Well, we know that this is 90 degrees. That's 25 degrees, and 90 minus 25 would be what? 65. So we know that this is 65. So there's no way that x could be smaller than 8, and that's what this is claiming it is. So evidently I'm entering that thing in my calculator wrong, and so I went and got my graphing calculator, which I do know how to use, and I plugged it in and I got 17.16. You guys, if you're watching this at home, you probably already figured it out because you had a calculator that you know how to use. So that makes more sense now, 17.16, because this would be significantly longer than the 8, because that angle is significantly bigger than that angle. Okay? So there's going over something you already know. Now we're going to apply law of sines to this. So the law of sines, and a lot of people, once they learn law of sines, they stop using this. Law of sines says that in any triangle, now here's the cool thing about law of sines, it doesn't have to be a right triangle. Notice this is only true in a right triangle. But the law of sines says in any triangle that you can take the sine of A divided by A, and that's going to be equal to the sine of B divided by B, which is also equal to sine of capital C divided by small c. Now, this is all under the notation that if you have a triangle, then it's understood that if we use capital A's for angles and capital letters for angles and lowercase letters for sides, and it's understood that if angle A is here, side A is the side opposite that angle. And if we say this is B, that means this must be B. And if that is capital C, this must be lowercase c. So this basically says, if you take the sine of an angle divided by the side opposite it, it's going to be equal to any other sine of an angle in that triangle divided by the side opposite it. So we never do all three at once. We're always just doing two of them. So I could do sine of A, for example, sine of A over A is equal to sine of C over C. I could just use that. Or I could do sine of B over B is equal to sine of C over C. We're always just using two at a time. And also, because we know how proportions work, that if this is all true, then it's also true that lowercase a over sine of capital A is equal to lowercase b over sine of capital B, etc. Okay, so it's just a ratio. Only use two at a time. Never do all three. But that's law of sines. Pretty simple concept. So we're going to take that and apply to this same problem and see if we get the same answer. We're trying to find x. So if we're doing law of sines, we first of all need to find... Now, law of sines, I said, works in any triangle, but we have to have an angle and the side opposite for it to work, because otherwise we don't have a ratio to compare to. So in this case, we're in luck because 25 is opposite 8. And I'm going to put the 8 on top and the sine of 25 on the bottom, just because I know I'm going to be looking for a side, so I'd rather have my variable on top, right? So over here then, I'm going to put x on top, the thing I'm looking for, and then I'm going to put sine of 65 degrees on the bottom, because that's the angle opposite the side I'm looking for. And so this sets up a proportion that I can solve. The way I solve this proportion is just multiply both sides by sine of 65 degrees. So that's going to give me 8 times sine of 65 degrees divided by sine of 25 degrees is equal to x. And I'm going to grab my calculator that I know how to use and do 8 times sine of 65 divided by sine of 25. And I get, lo and behold, 17.16-ish. Okay, so that's law of sines. Isn't it nifty? Now, the cool thing, like I said about law of sines, is we don't have to have a right triangle to use it. So let's say, for example, I have this triangle. And let's say we know that it looks almost like an equilateral triangle. Maybe it is. Oh, I think it is. Let me grab one that's not. I think that just draws the right triangle. Don't have any other options here? Bummer. Okay, well. Maybe I'll just draw a triangle. So let's say we have a triangle that looks like this. And we know that this angle is 32 degrees. And we know that this side is 7. And we want to know what that side is. Okay, now notice, because this is not a right triangle, we cannot use the known trig ratios that we've learned so diligently. So the sine is equal to opposite over hypotenuse or the cosine is equal to adjacent of hypotenuse or tangent is equal to opposite of adjacent. None of those work in this triangle because this is not a right triangle. Those are only true of right triangles. So we're going to have to use law of sines. Now we hope that we can use law of sines. And remember, the condition for using law of sines is you need to know an angle in the side opposite, which we do. And we're looking for this side over here. We actually have to know one other angle. So we need to know an angle in the side opposite it and one other angle, or an angle in the side opposite and one other side. So let's say that we know that this is 40 degrees. Okay? So now, if we want to use law of sines to find x, we would go 7 over sine of 32. Notice I put the side on top again because I'm looking for a side. If I was looking for an angle, I put the angle on top. Okay? And that's going to be equal to, well now, I give you 40 degrees, but that's not really the right angle, is it? We really want to know what this angle is, because that's the angle opposite the side I want, because I'm going to put x up here, and I need to know that angle. Well, I can find that angle because we know the angles of the triangle add to 180. So 180 minus 72, because 40 plus 32 is 72, would give me 108. So this angle is 108. So I'm going to put over here sine of 108 degrees. We're going to solve that by multiplying by sine of 108 over sine of 32. And grab my calculator that I know how to use. And I go 7 times sine of 108. By the way, make sure you're in degree mode here because we're plugging degrees into the calculator. So we want to make sure it's speaking the same language as us. And then we divide that by sine of 32. And we get 12.56 is approximately equal to x. Now let's say we also wanted to know this other side over here. That's no problem. We'll just take 7 over sine of 32 again. And put a, I don't know, just to use a different variable, we'll put a b or something like that. And this time, instead of putting sine of 108 down there, we're going to put sine of 40. Because that's the angle opposite the one I'm looking for now. So then once again, we'll grab a calculator and we're going to do 7 times sine of 40. Divide that by sine of 32. And we get, so let's see, what did I just say? Sine of 40, because we're just multiplying both sides by 40, right? So that's going to be equal to approximately 8.490. So my triangle would have this side we said was 12.56 approximately, and this side was 8.49. So what we've just done is we basically have solved this triangle. So that's a vocabulary you need to use. So, because I'll just say that sometimes I'll give you a triangle with a couple pieces of information. I'll say solve the following triangles. That just means find all the missing sides and angles. Notice we found one of the missing angles by just subtracting the two given angles from 180 to get the third one. That's a good thing to keep in mind, that you don't find something the hard way when you have the easier way. So if you know two of the angles, you don't need law of sines to find the third angle. You can just subtract it. So let's do a law of sines where we're finding an angle. So let's say we got a triangle like this, and we know that this is 28 degrees, and we know that this is 10, and we also know that this is 14. And we want to know, well, let's just solve the triangle, okay? Now that looks like it's close to 90, but it's not. Is it not? Yeah, no, it's not. 25 and 35 is 7. Yeah, it's not. Okay. So again, you can't really, if I'm just drawing a triangle randomly, you can't really go by the way it looks to determine, because sometimes I draw these pretty roughly. So, okay, so anyway, we want to find the two missing angles and one missing side. So I'm going to find this angle first because I'm curious how close to 90 it is, because it looks 90, but it's probably not even close. Okay, so this time I'm going to put sine of 28 on top because I'm looking for an angle this time. And I'll put 10 on the bottom because that's the side opposite of 28 degrees. And I'm going to set that equal to something over 14. Nope. Shoot, I can't find that one first. Okay. Guess I'll have to find that one first. Yeah, because I have to use the side that I know, right? I know 14, which means I need the angle opposite that. So we'll call this A just because. So this is going to be sine of A. And so then we got to solve for this. So I'm going to multiply both sides by 14. So that'd be 14 sine of 28 degrees over 10 has to be equal to sine of A. And throw this in my calculator. I'm going to go 14 times sine of 28 divided by 10. And I get approximately 0.65726. But notice that's equal to sine of A, right? That's not the answer we're looking for. So how do we get the A? We got to undo sine. So we're going to take arc sine of that answer we just got. And that's going to give me 41.1 degrees. So now we know that this is 41.1 degrees. Okay, now, I would immediately at this point, since I'm trying to solve the triangle, I'm going to use law of sines now. I know that this is 28, that's 41.1, so I'm going to add 28 to that angle I just found, and I'm going to subtract that from 180, because I know the angles of the triangle add up to 180. So when we found out that, and we'll call that B just for fun, so that we just found out that B is approximately equal to 110.9. That's 110.9. So now we have all three angles, and all we're missing is the side. Since I called that capital B, we'll call this lowercase b. And so then, once again, I'm going to use the known one. I don't want to use found angles. I'm going to use the ones that are given to me. So, and this time I'm looking for a side, so I'm going to put 10 on top, sine of 28 on the bottom. And that should be equal to B over sine of 110.9 degrees. Okay? And then we're going to multiply both sides by sine of 110.9. So we got 10 times sine of 110.9. Whoops, I forgot my decimal. 0.9. And I'm going to divide that by sine of 28. And so we end up with 19.9, approximately equal to B. So we've just solved this triangle. We were given 28 degrees, a side of 14 and a side of 10, and we were able to find all the other pieces using law of sines and subtracting from 180. So now I'm going to do one more example. I won't do it all the way through, but just for the setup. Sometimes you'll get the problem given to you like this. They'll say like A is equal to 5, B is equal to 7, and capital B is equal to 42 degrees. Okay, so there's no triangle drawn. So you're going to have to draw the triangle yourself. Now the key here, of course, for law of sines is just to make sure you're clear on what sides are opposite which angles. So you don't have to worry so much about drawing the angles and sides accurately. So I would just do something like this and then call this B, which means that's 42 degrees, which would mean this has to be 7 over here because B has to be opposite capital B, right? And then it doesn't really matter if we pick this to be 5. That would force this to be capital A, and that would force this to be capital C, and then that would be lowercase c. So you just begin somewhere on a triangle and start putting in information, and all you have to do is make sure that small a is across from big A and small c is across from big C, and you will be able to calculate the answers correctly. Because usually what will happen here is they'll say solve the triangle, or they'll say find A, which would mean find the angle opposite of the side length 5. Okay, so just to know that all that information works. Okay, now notice the one I just drew here. This one is a special case that we'll talk about in the next video. So don't try to solve this on your own. There's some dangerous pitfalls here. Okay.